Hi class, this is Sir Alex Basco and welcome to our lesson in Chemistry 2. Today we'll be discussing lesson 6.2, which will be about concentration of solutions. Today you will learn how to express various concentrations of solutions. Today, the goal would be for us to be able to use different ways of expressing concentration of solutions. More specifically, today you will learn how to express concentration of solution using percent mass, mole fraction, molality, percent by volume, percent by mass, and parts per million. So we'll begin our discussion with discussing what is concentration of solution. So basically, concentration of solutions tells us how much solute is present per given amount of solution or given amount of solvent. I hope you guys remember the difference between solute, solvent, and solution. Solute is basically the particles or the molecules present in a solution, and the solvent is the one that you use, usually in liquid form, to dissolve solutes. And we use concentration of solutions as a conversion factor, especially when we are dealing with stoichiometry, which will be our next lesson with lesson 6.3. But today we'll focus first on concentration of solution. And the amount of solute may be expressed in terms of mass or in moles. And usually in concentration of solutions, the solute always appears in the numerator. Moreover, the quantity of solvent or solution may be expressed also in terms of mass, grams or kilogram, or in volume, in milliliters and liters, and it usually appears as the denominator of your concentration. As you can see here, we usually express concentrations of solutions as quantity of solute over quantity of solution or quantity of solute over quantity of solvent. Always remember that in concentration of solution, the numerator is always the solute and the denominator can either be solution or the solvent. Now let's talk about percent by mass or percent by weight. So what is percent by mass? Percent by mass is the ratio of mass of solute divided by the mass of solution. So when we talk about percent by mass, we are talking about the mass of solute and the mass of solution. And it's usually in terms, we usually write them in terms of grams. So mass ratio, we call this ratio, this ratio of mass of solute over mass of solution as mass ratio. And it is a decimal fraction, meaning it's basically a decimal form of a fraction that represents mass of solutes in 1 gram of solution. 100 times the mass ratio is percent by mass, which is the grams of solute per 100 grams of solution. It's a lot of words, but in simplest term, this is the equation that we use when you want to look for percent by mass. So we divide the mass of solute to the mass of the solution, and then we multiply it by 100 since we're looking in making it a percentage. So by multiplying the mass ratio, this is the mass ratio right here. By multiplying it to 100, we can get the percent by mass. It's basically how much mass of solute is in there in every 100 grams of solution. And percent by mass, it is important to understand the difference between solution and solvent. So note that the solution is equal to the sum of the mass of solute and the mass of solvent. Therefore, we can also use this equation. Percent by mass is equals to the mass of solute divided by the mass of solute plus the mass of solvent. Because the mass of solution is basically the mass of solute plus the mass of solvent. Again, I hope you guys understand the difference between a solution and a solvent. Solution includes both solute and solvent. Solvent is the one that you use to dissolve the solute. Kumbaga, in your coffee, if you guys are drinking coffee, the solute or the coffee grounds or the coffee powder that you use, and the solvent is the water. And the solution that you ended up getting is basically the coffee that you drink. So the mass of that coffee that you drink is equal to, or basically the mass of that solution is equals to however grams of coffee grounds or coffee powder you put, and the mass, again, not the volume, we're talking about grams, talking about mass of the solvent, or basically the hot water, the mass of the hot water you use in your coffee. By adding these two, you can actually get the mass of your solution. And then by getting the mass of the solute divided by the mass of the solution and multiply it by 100, you'll get a percent by mass. Note, be careful of the denominator. If the problem gives the mass of solute and mass of solvent, in order for you to get percent by mass, you have to add the mass of solute and the mass of solvent to get the mass of solution. So let's try it in problem 6.2.1. When 125 grams of solution was evaporated to dryness, 42.3 grams of solute was recovered. What was the percentage concentration of the solution by mass? So let's try and solve this. Let me just change my pen. Okay, so let's begin solving this by first writing all our given. That way we won't get lost in how what is happening on the problem. So first, let's identify our given. In here, we are given that 125 grams of solution, so that's easy to remember. So we first gave us 125 grams of solution, and then after evaporating it by boiling it to dryness, means we remove all the solvents, we got 42.3 grams of solute. So after evaporating the solution, we basically get 42.3 grams of solute. Then the question is, what is being asked is what is the percentage by mass. So what is the percent by mass? So the formula that we are going to use is the formula that I showed earlier. So it's basically percent by mass is equals to the mass of solute divided by the mass of solution, since we got solution. So how we solve this? So the solution, basically have to write the values of the mass of solute and the mass of solution. So percent mass is equals to 125 grams of solution, no solute, 42.3 grams of solute divided by 125 grams of solution. And the answer for that would be 33.8%. Oh, you have to times it by 100, so 33.8%. So it's quite easy. That's how you get percent by mass, or how much percentage of solute is there in 125 grams of solution. So there is 33.8% of solute in that whole solution. So let's try another problem. Problem 6.2.2, we're still in percent by mass. If 28.5 grams of calcium hydroxide, CaOH2, is dissolved in enough water to make 185 grams of solution, what is the percentage by mass of calcium hydroxide in the solution? Okay, so let's begin by writing our given. So we were given 125 grams of calcium hydroxide, and since we know that it is the one being dissolved, we have we should know that this is the solute because it's the one being dissolved. So we are given 28.5 grams of calcium hydroxide, and then we were also given water to make and dissolving enough water to make a 185 grams of solution. So we have 185 grams of solution. In this case, this is a calcium hydroxide aqueous solution. So what is the percentage by mass of? So what are being asked? What we are being asked is the percentage by mass of the solution. So the formula that we are going to use is basically the formula that we've just talked about. So percent by mass is equals to the mass of solute divided by the mass of solution times 100. So solution, basically just have to substitute the number. Percent by mass is equals to 28.5 grams of CaOH2. This is our solute divided by 185 grams of the CaOH2 solution. Okay, so what we are going to get if we times 100, sorry, I always forget that, times 100, and we'll get 15.41%. So what that means is that 28.5 grams of 185 is actually 15.41%. So 15.41% of 185 grams is basically 28.5 grams. So it's quite easy. That's how you solve percent by mass. So just remember, in percent by mass, you usually have to multiply or divide the mass by mass over mass. So you should have the mass usually in grams of the solute and the mass of the solution. And moreover, if they gave you the mass of solute and solvent, you have to add both in order to get the mass of solution. So that's uh, quite easy. I hope everyone gets that. So that is percent by mass. Now let's move to percent by volume. If percent by mass is basically the ratio of the mass of solute over the mass of solution, percent by volume is basically almost the same. It involves the volume of both the solute and the solution. What that means is that it's basically percent by volume is basically the volume of the solute divided by the volume of the solution. So previously we've discussed mass and mass of solution. At this time it's the volume of solution. So we're talking about milliliters. You usually use milliliters in percent by volume. Moreover, one thing that I want you guys to remember is that volume is not additive. Unlike in percent by mass, where we can have mass of solute plus mass of solvent is equals to the mass of solution, you cannot get the volume of the solution by adding the volume of the solute or the volume of the solvent. Why is that? It's because unlike mass, volume is not conserved in addition of the two volumes. There's a lot of reason for this, but I'm not going to go deep into that. Just remember that you cannot get the volume of the solution by simply adding the volume of the solute and the volume of the solvent. Again, you cannot get the volume of the solution. Example, In order to make 240 ml of ethanol solution from 40 ml of ethanol, so you want to make a 240 ml of ethanol solution, meaning ethanol plus water solution. And you start with 40 ml of ethanol. Okay, so your end goal is to create a 240 ml of ethanol solution. And you start with 40 ml of ethanol. You cannot just simply add 200 ml of H2O because this will not equal to the to 240 ml of ethanol solution. What actually, because they actually have different densities. The density of ethanol is different from the density of water. By adding those two densities together, you're going to end up not having, actually, you won't have enough 240 solution by adding 40 and 200 water. What actually happens is it creates less than 240 ml of solution. What you need to do when creating or preparing solution by volume is that what you need to do is to keep adding water until you reach the desired amount. So meaning you start with 40 ml ethanol and then you keep adding H2O until you get 240 ml. So the end goal is to get 240 ml of the solution that you want. And the amount of water you get is, it depends until you reach your desired volume of your solution. So what that means in this scenario is that you actually add more than 200 ml of water. Because again, it's not additive, this is not conserved. If you add just 40 ml of ethanol and 200 ml of H2O, you will not get 240 ml of ethanol and water solution. Because again, they have different densities. When you add them together, it will not equal to 240 ml. What you need to do if you want to get 240 ml is start with your solution, or your, in this case, your solute, which is ethanol, and then keep adding water. So you can imagine it as in a graduated, maybe in a flask. You start with 40 ml of ethanol and then just keep adding and adding water until you reach 240. And the amount of water is, it doesn't matter. What matters is you reach the 240 ml that you want. So I hope everyone understands that. That's just an example, but that's how you prepare solution by percent volume. So how do we solve percent by volume? So we use this equation to solve for percent by volume. You have to have your volume of solute divided by the volume of the solution. So let's have this example. This is supposed to be wine, not wine. A wine contains 12% alcohol by volume. Calculate the volume in ml of alcohol in 350 ml of wine. So in this case, it's a little different now. So let's write our given. So instead of giving us the volume of the solute, they first give us the volume, or the percent by volume. So the percent by volume of the solution is equal to 12% alcohol. And then the total volume of the solution is 350 ml. So this is your solution, volume of your solution, and this is your percent volume. So they give us the volume of the solution which is equals to 350 ml of wine. So what they were asking us is calculate the volume of alcohol. So they're asking for the volume of the solute, which is the alcohol. So how to do that? It's basically we just have to rearrange our equation. We know that our equation is that percent volume is equals to the volume of solute divided by the volume of solution multiplied by 100. So in order to solve that, we just have to rearrange our equation here. So we're solving for the volume of solute. So volume of solute is basically equal to percent volume, percent by volume multiplied by the volume of the solution divided by 100. So if we just have to plug in the number, which is 12 multiplied by 350 ml divided by 100, and that would actually give us 6.0 no 42, not 6, 42.00 ml of alcohol. So that's how you use percent by volume in this situation. So if you want to solve for volume of solution, you just have to rearrange the equation. So for example, they gave you the volume of the solute and they gave you percent by volume, and they're looking for volume of solution. You just have to rearrange the equation. So volume of solution, what happens then is basically volume of solute divided by percent by volume, and that's also you have to multiply it by 100. That's how you get the volume of the solution. Okay, so I hope that's clear. So the only difference is that percent by mass and percent by volume is basically mass divided by mass, and volume is volume divided by volume. So you just have to make sure that you're doing grams per grams, kg per kg. You cannot do grams per kilogram. That will mess up your answer. You have to use the same expression, ml divided by ml or liters per liters. But you have to use the same expression. Or also, and they are expressed in the same units. Okay, I hope that's clear. So that's percent by mass and percent by volume. Now let's move to percent by mass volume. So now we are gonna mix the two. So we're gonna measure the concentration of solution by mass and by volume. So how is this different? Sorry. So it's basically the ratio of the mass of solute. We usually use it in grams present in the solution relative to the volume of the solution. We usually use ml as a whole. So what that means is basically percent by mass volume is mass of the solute divided by the volume of the solution. You can think of it as solute usually is in solid form and volume usually in liquid. So I think that's more intuitive to think for you guys, to think that we are dissolving some solids in a liquid solution or in a liquid solvent. Okay, so how do we use this? Here's an example. A 50 ml of 12% mass volume solution was used in the experiment. How many grams of solute does the solution contain? Okay, so let's first write our given. So the first given is that we have a 50 ml of solution. So what that means is that, let's move this given right here. We have 50 ml, and that is the volume of the solution. And then we are given the 12% mass volume. So we are given 12% as the percent by mass volume of the total, or the concentration of the solution. So what they were asking us is how many grams of solute. So they're asking the mass of solute does the solution contain. Okay, so they gave you the total volume of your solution, they gave you the percent mass volume, the concentration, then they're asking you the mass of the solute. So how are we going to do this? Basically, we just have to rearrange the formula, which is percent mass volume is equals to the mass of solute divided by the volume of the solution multiplied by 100. So in order to get the mass of solute, we just have to rearrange the equation, which is mass of solute is equals to percent by mass volume multiplied by the volume of solution divided by 100. We're just plugging in our numbers. You have 12 multiplied by 50 ml divided by 100, and that is 6.0 6.00 grams. 6.00 grams of sodium. Okay, so that is how we solve uh, um, mass volume equation. So again, the mass is solute, that's just the difference, and volume is the solution. It's basically just a mixture of mass by percent by mass and percent by volume. Okay, so I hope that's clear. Let's move on to mole fraction. So this is now a little more challenging, and I hope you guys would understand it as I try to explain what is happening in mole fraction. So mole fraction expresses the relative amounts of substances in a mixture. What that means is that it's a ratio of mole of one substance in a mixture to the total number of moles of all substances. Okay, so it's the ratio mole of one substance. So you have a mole of one substance. Basically, you divide it by the total number of moles of all substances present in the solution. For example, you have a mixture of two substances. You have A and B. And you want to get the mole fraction of A and B. What you want to do first is, for example, you want to get the um, uh, mole ratio. You have In order to get a mole ratio, you first have to get the mole fraction for A by taking the moles of A and divide it by the moles of A plus the moles of B. So this is how you would get the mole fraction of A. This is the mole fraction for A. What else you want to do is, this is for two substances, is you have X plus B. So if you want to get the mole fraction for substance B, you have to get the moles of B and divide it again by the moles of A plus B. As you can see, moles of A plus B is basically the total moles present in the solution. Okay, and the moles here is a mole of one of the substances you added in the solution. And one thing that is interesting then is that if you add those two mole fractions, you would get always 1. So what if you have a mixture of three substances? You have basically just have to do the same. Uh, for the mole fraction of the third substance, if you have three substances, you have to have the mole of your third substance and divide it by the moles of all the substances present. And what is interesting is if you add all of those, xa plus xb plus xc, it would still equal to 1. So you can think of this as parts of the totality. So this mole fractions is a singular one part of the mole of all the total moles in the solution. So how do we get moles? So probably you guys are wondering, so what is moles? How do we get moles? So in order for you to measure moles, you need two things. You need to have the mass of the substance and its molar mass. So yeah, and then you have to divide the mass of the substance divided by the molar mass. In a lot of problems, usually the molar mass is given. But just a quick review, or I hope you guys know how to get the molar mass. If not, just a quick review. For example, how do we get the molar mass of a molecule? Let's think of an example as H2O. If you look at the periodic table, you would see two numbers per each element. And it's usually the one on top and the one at the bottom. I believe, yeah, that's the thing. So you usually have to get the number at the bottom, which is actually what we call the atomic number. And what you're gonna do is you have to add this in your molecule. So in my molecule, I have H2O. What I need to do to get the molar mass then is basically, since I have two atoms of hydrogen, so I mean I have 1 multiplied by 2 because I have two atoms of hydrogen. And I have one atom of oxygen, so I just need to add plus 15.99. So basically what that is 16, 17, and 18. So 18 would be the atomic mass. It is what we call the atomic mass of the molecule. And the atomic mass is basically the molecular mass. So for example, I have 1 gram of oxygen or of H2O. So how many moles is that? So what I need to do is basically divide 1 gram divided by 18. 18, this is actually grams per mole. This value right here is grams per mole. So the mole, how many mole is there in 1 gram of H2O? So 1 gram of H2O has 1 over 18 moles. So I'm not sure what's the answer there, but it's 1 over 18. So that's the value of the mole. I hope that's clear how to get the molar mass. You don't really need to do a lot of these calculating the molar mass because usually it's given in the problem. Like our example here. So sample problem 6.2.5. Calculate the mole fraction. So we are calculating the mole fraction of sulfuric acid H2SO4 in 8% aqueous solution H2SO4 solution. So the molar mass of sulfuric acid is 9.076 grams per mole. So how do we get that? You just have to basically add the atomic number of 2 hydrogen, 1 sulfur, and 4 oxygen. We're not going to do that because it's already given. And as you can see here, this is our equation earlier of H2O. So 18, so it's very close to the molecular mass that I showed you earlier. So the molecular mass of H2O is 18.016 grams per mole. Okay, so how are we going to do this? So let's write our given first. So we're asking for the mole fraction of sulfuric acid in 8% aqueous solution. So our given is the mass of the we have the mass of the solution. Um, we know that because 8% of aqueous solution is basically 8 grams of the whole solution. So the mass of the solute is equals to 8.0 grams. That came from 8% aqueous solution. So what that means is that in a 100% solution, you have 8% of that solution is H2SO4. So if you have 100 grams of the solution, so you basically have 8 grams of H2SO4. I hope that's clear. Again, so when we say 8% aqueous solution, so if I have 8% aqueous H2SO4 solution, what that means is if I have 100, 8% of 100 is 8, right? So if I have 100% of H2SO4 solution, it means I have 8 grams of H2SO4 in that solution. Okay, I hope that is clear. And next we have the molar mass of the solute, which is 98.076 grams per mole. We also have the mass of H2SO4, or basically the solution. And like I said, 8% H2SO4 solution, that's 8 grams H2SO4, meaning the rest, the 92 grams, is basically the solvent, which is basically water. The mass of the solution is basically 82.0 grams. And the molar mass of the solution is equals to 18.016 grams per mole. Next, what are they asking us is the mole fraction. Okay, so how are we going to do that? It's basically using the formula that we have. We have two substances. So in order to get the substances of something, so in this case you have A, so that's the mole of A divided by, and the moles of A plus the moles of B, have XB, mole fraction of solution B, you have the moles of B multiplied by Na, moles of A plus the moles of B. And then for, yeah, so that's how what we're going to do. Or over also, we have to get the moles. We know that the moles is basically the mass over the molecular mass of the substance. Okay, so these are the equation that we are going to use. Okay, so solution. So let's begin by using or looking for the mole fraction of H2 SO4, sulfuric acid. So in order to do that, we have to get the mole first. In order to get the mole, we just have to get the mass of the solute, which is H2SO4, and divide it by its molecular mass. So we have 8.00 grams of H2SO4, and its molecular mass is 89.076 grams per mole, and that yields to 0.086816 moles of H2SO4. After getting that, we have to get the mole for H2O, and we have 92 grams of H2O divided by 18.016 grams per mole, which is the molecular mass of water, and that will give us 5.1066 moles. So in this solution we have 0.0186 mole of H2SO4 and 5.100066 moles of H2O. Next, in order to get the mole fraction for XA, so let's use this as our A and this is our B. So XA is basically 0.0816 moles divided by 0.0816 mole plus 5.1066 mole, and that equals to 0.02 mole fraction. And mole fraction doesn't have a unit, so next you have XB, which is basically this 5.1066 mole, which is the mole of your second substance or the mole of water, divided by 0.0816 mole plus 5.1066 mole, and that is actually 0.098 mole fraction. And to check, you know that XA plus XB should be equal to 1, and you know that 0.02 plus 0. Oh, not 0. That's not 0.0. 0.98 is equals to 1. You can also use this, just substitute XA and subtract it to 1, you will get XB. You don't need to do this, but just to make sure that you're actually correct. And that's how you solve for the mole fraction. So the answer is 0.02 of H2SO4 to 0.98 of XB or H2O. Okay, so that is how we get the mole fraction of two substances in a solution. Okay, next, molality. So molality is, do not confuse it with molarity or moles. Molality is basically the ratio of the number of moles of solute in 1 kilogram of solvent. So we're dealing with moles of solute again. Remember, moles is equals to the mass of your solute, or basically your substance, divided by the molecular mass of the substance, not solute. And then we are dealing with solvent, not solution. We are dealing with 1 kilogram of our solvent. So molality is equals to moles of solute divided by the mass of solvent. As you can see, this is mass, and in moles, that is another way to express quantity of a solute. Okay, so how do we do that? First, you have to know that the unit for molality is molal, or use the small letter m. A solution containing 1 mole of solute A in 1 kilogram of solvent has a concentration of 1 molal of A. That is because we have 1 kilogram of solvent, and inside that 1 kilogram of solvent we have 1 mole of solute, in this case solute A, so that means 1 molal of A. Okay, simple problem. Calculate the molar concentration of a solution that contains 8 grams of sodium hydroxide. So this solution contains, so meaning this sodium hydroxide is our solute in 100 milliliters of water. So this is our solvent. The molar mass of sodium hydroxide is 39.998 grams per mole. So let's write our given. So we are given that the mass of our solute is 18 grams, and we are also given the volume of H2O, which is our solvent, which is 100 ml. And lastly, we are given the molecular mass of NaOH, which is 39.998 grams per mole. What we are being asked, the molar concentration, so the small letter m. Formula is the one we talked about earlier. So the formula is basically molality is equals to the moles of solute divided by 1 kilogram of solution, or in this case our solvent. Okay, and this time you don't need to times it by 100. Okay, so how are we going to do that? First we have to get moles, because as you can see they gave us the mass of our solute and the molecular mass, but not the moles. So what we have to do first is to get the moles of the solute. And we know that the equation for the moles of solute is basically the mass of the solute, or the substance, divided by the molecular mass. So we have 18 grams of NaOH divided by 39.998 grams per mole, which is the molecular mass of our NaOH, and that is actually equal to 0.45 moles of NaOH. But we're not done yet. We have to, as you can see, we are looking for kg. We're looking for the kilogram of the solvent, but what they give us is 100 ml. So what we have to do is use density, using the density of water to convert volume to mass. So we know that we have 100 ml of H2O. In order to convert that, one of the common knowledge that we have is that we know that in 1 gram of water we have 1 milliliters of H2O. So meaning the density of water is basically the relationship between volume and mass. 1 gram H2O is equals to 1 milliliter of H2O. So that is a common knowledge that I want you guys to always remember. Density of water, 1 gram H2O is equals to 1 milliliters of water. So we can change or remove ml, and then we have to change grams to kilograms. And we know that 1000 grams is basically equal to 1 kilogram, which gives us the value of 0.100 kg of H2O. So now that we have the moles and we have the kilogram of the solution or the solvent, now we can solve for molality, which is the moles of solute, which is 0.45 mole of NaOH divided by 0.1 kilograms of H2O. And that gives us 4.50 molal of solution. Okay, so this is a lot more work, but I hope that you guys understand what happened. First, you have to understand how to derive moles. So one important thing is to understand how to get moles. Moles is basically the mass of a substance divided by its molecular mass. And then you have to also understand the density of water. When they give you a situation like this, for example, it's not water, they would usually give you the density of that liquid solution or liquid solvent in order for you to convert it to mass. So you just have to make sure how to perform conversion. A lot of this is basically conversion, so I hope you guys understand that. So after you get the moles and the kilogram or the mass of the solution or the solvent, you just have to divide both to get molality or the molality of the solution. Okay, so that is molality. Next one, we're going to talk about molarity. Very similar with molality, but instead of kilogram of solution, we are talking about a liter of solution. If you guys remember, if we are dealing with water, you guys remember 1 gram H2O is equals to 1 milliliters of H2O. In this scenario, it's kind of similar, but instead of dealing with in molality, we get mass over mass of solvent, moles over mass of solvent. In molarity, which is capital M, actually is mole over volume. Okay, so what happens is in molarity, we are looking for the moles of solute, but we have to divide it by the volume of solution. In molality, we use the mass of solution, but in molarity, R, we use the volume of solution in liters. Another thing is, especially you have to kind of like understand this because you would use a lot of this in stoichiometry. It's a conversion unit that you use in stoichiometry. The unit of molarity is molar, which is a capital M. 1 molar solution of A contains 1 mole of solute A in 1 liter of solution. Okay, sample problem 6.2.7. Determine the molar concentration of solution that contains 25 grams of potassium hydroxide. So the solution contains 25 grams of potassium hydroxide. So we know this is our solute and 250 ml solution. So this is the volume. Okay, so let's write our given. Our given, the mass of solute, which is 25 grams. This is 25 grams of potassium hydroxide and we are given the volume of solution, which is equals to 250 ml. And what they're asking us is the molar concentration. Formula: M molar concentration is equals to the mole of solute, not mass, you have to get the mole, divided by 1 liter of solution. Okay, so we're going to solve this. Okay, first we have to get the mole of the solute. In order to get that, they gave us the mass and they gave us the molar mass of the solute. So we can basically have 25 grams divided by 56.180 grams per mole. And that yields to 0.4456 moles of uh, potassium hydroxide. Okay, after getting that, we have to first convert our volume, because we know that volume must be in liters, and they gave us 250 ml, and that is actually equal to, there's 1000 ml in 1 liter, so that is actually basically equals to 0.25 liters of solution. And lastly, we can solve for molarity, which is basically dividing the moles of solute to the liters of solution, and that gives us 1.78 molar of solution. Okay, so that's how we perform molarity. So it's basically the same. The only difference with molality, the only difference is that in molality, we divide it by 1 kilogram of solution. In molarity, we divide things by 1 liter. Okay, so I hope that is clear. And we're gonna go on to our last, which is parts per million. So parts per million is quite easy. I'm not gonna spend a lot of time here. But parts per million is basically you express the number of parts, expresses the number of parts of solute per 1 million parts of solution. So parts per million is equals to the grams of solute divided by uh, the grams of solution. So what that means is that I have, you kind of like imagine as you divide the solution in parts, and you divide it by, let's say, 1 million parts. In that 1 million part, you took one from that 1 million, that is parts, basically parts per million. You can think of it as 1 is 1% of 100, correct? You can think of 1 is basically 1 parts per million of 1 million. So you basically divide your solution into million, and then you take 1, and that 1 is your solute. So that's basically the concept of parts per million. And not there's a lot of ways to express parts per million. We can also use milligrams per liter, which is the mass of solute in milligram, 1 milligram per 1 liter of solution. And it usually depends on the given situation. 1 parts per million is equals to 1 milligram per 1 kilogram, 1 kilogram, or is equals to 1 milligram per 1 liter, or as you can see here is basically equal to 1 gram over 1 million gram. Okay, so consider 1 gram of pollutants in soil. So basically 1 parts per million is equals to 1 gram of pollutant in 1 million grams of soil, and that is equals to 1 grams. You convert it to milligrams. We know that there's 1000 milligrams in 1 gram. Then all of this divide to 1 million of soil, and then let's divide this soil to kg. 1 kg is equals to actually 1000 grams. This is just conversion units, guys. 1000 milligrams is equals to 1 gram, so we can cancel the gram. We can cancel the gram here. 1000 grams is equals to 1 kilograms. So this is basically 1000 mg divided by 1 basically divided by 1 times 6, 1 times 10 to the 6 divided by 1000 kg, which is equals to 1 milligram of pollutant per 1 kilogram of soil. Okay, so it's just basically conversion of units. So 1 ppm is equals to 1 mg over 1 kg, or 1 mg over 1 liter, or is basically 1 gram over 1 million grams. Okay, so again, parts per million, we're not gonna spend a lot of time about parts per millions, but one thing that I want you guys to keep focusing on is molarity, and especially you're going to use that in stoichiometry. So that's how we express a lot of concentrations of solutions. If you guys have any questions, just message me anytime, and I hope you guys have a good day.